Okay, this is a continuation of MAC 1140 Pre-Calculus, Section 10.4. And in this video, we're going to be doing numbers 11 through 17. Okay, we begin with number 11. It says, find the center, transverse axis, vertices, foci, and asymptotes, as well as graphing the equation. So in this particular problem, notice that it is not in the standard form that we need it to be in when we're going to graph. Those forms have a 1 on this side of the equation for the constant. And so I'm going to start this problem by creating a 1, which will then give us the fractional forms that we need for both of these terms, where the denominator will tell us what a squared and b squared is. So start by creating a 1 here. This is going to work. Dividing this by 196 and dividing this by 196. And if you want to get your calculator to help you reduce this fraction, you can just put 4 divided by 196 and then hit math, enter, enter. So that's 1 over 49. So this, instead of 4 over 196, it'll be 1 over 49 in your x squared term. Okay, the 1 is the coefficient of the x squared. There's the 49. And then you have no coefficient in front of this y squared. And then you have the 1 that you need. So now it's in the proper form, and you can also tell what a squared and b squared is. Again, the a squared term is always associated with the positive expression, and therefore a is equal to 7. You'll use the a squared value when you write the equation, but the a value of 7 when graphing. This would be the b squared value. And if b squared is 196, just take the square root and you have the b value, which is 14. Okay, so we know that b is 14, and we know that a is 7. Okay, so the center of the hyperbola. Notice that neither the x nor the y expression have x minus any number or y minus any number, so the center is still at the origin. So center of the hyperbola, 0, 0. What is the transverse axis? Well, notice that the x expression, the x term, is positive. And therefore everything is aligned horizontally along the transverse axis. Therefore, transverse axis is horizontal because the positive term refers to the x-axis, which is horizontal. So transverse axis is the x-axis. Okay, where are the vertices? Well, they'll be situated along the transverse axis, which is the x-axis. So if you're at 0, 0, and you're going to move to each of these vertices, and you know those vertices have to be oriented along the x-axis, that means you're going to be moving to the right and to the left of the center. Okay, so you are moving a distance of 7 units. That means that your vertices moving from this center, you're going to be going 7 to the right. And remember, when you're when you know what your center is, and you just want to move to the right and to the left, you're either adding something to the x, 7 in this case, because to go from center to vertex to either one of the vertices, you're adding the a value. So that a value is 7. That means you're 0 plus 7, you're at 7, 0. And when you move this way, you are subtracting 7. So it would be 0, take away 7, negative 7, 0. Those are your vertices. Okay, the foci. The foci are located C units from the center. So we need to figure out what the C value is. So again, remember that there is a relationship between A, B, and C given by this equation. It's B squared is C squared minus A squared. Okay, so we're going to take the B squared value that we have, which is 196. And we're going to take the A squared value that we have, which is 49. And we're going to solve for C squared. So if you're solving for C squared, that means you're going to be bringing this negative 49, at which point it will be positive 49. So you'll end up with C squared is equal to 196 plus 49, which is 245. Okay, so this is 245. And you actually have to give exact values on that foci. So this C value, we need to know what the C value is. So we're going to take the square root here. We're going to take the square root here. So we need to know how this breaks down so we can give exact values. So see that it says for the foci that you should type an ordered pair, type an exact value using radicals as needed. So we may be able to think about this as a decimal approximation when we graph, but we cannot use that decimal approximation when giving the foci because they want exact answers, meaning do not get a decimal and then just go and round it off. That's only good for graphing purposes. So I believe 5 goes into this if it ends in 5, so this is 5 times 49. You can take the square root of 49, that would come out as a 7, while the 5 would stay inside. So C is, in its exact form, 7 times square root of 5. Again, 49 comes out, you're taking the square root while the 5 stays inside. This is approximately, if you want to know a decimal approximation for when we go to graph, approximately 15.7. If you put that in your calculator, square root of 245. Okay. So we also have this C value. So if we're going to try and give the foci, again, all of this is lined up. You can plot the center right here. You can plot the, let's see, what do we get? The vertices. The vertices are at 7, 0. And I think I'm going to count in 2s along my x-axis. So 2, 4, 6, 8. This will be 8. Therefore, 7 will be right there for one of my vertices. And 2, 4, 6, negative 8 will be right there. Therefore, negative 7 will be right there for my other vertice. And then the foci are even further out because the vertex comes first, and then you run into the foci. So you don't have to put that in the graph, but you do need to be able to name them. The graph just gives you a sense of how is everything oriented. So you go from center out to the vertex, and if you move a little further, they always have to be all lined up. So this is the transverse axis, the x-axis. Then you know that you're just moving to the right and to the left of this center point right here. So again, the center was at 0, 0. We are moving to the right and to the left to get to our foci, to either one of our foci. And when you're moving to the right, it's just a matter of adding a particular value to x, and that value is the C value. Our C value specifically is 7 square roots of 5. Make sure you're adding it to the x, not to the y, because that's what it means to move to the right or to the left. You're adding something to the x. So 0 plus 7.7 times square root of 5 is 7 square roots of 5, while the y coordinate remains unchanged. If you're going to move this way, then you're taking the x value and subtracting that c value of 7 square roots of 5. So the other foci would be negative 7 square roots of 5. Leave the y coordinate unchanged. Okay, so that would be, I'm going to just leave them here. It's a little bit too much to squash into that box. So that's one foci. Here's your other one. Okay, then let's see what else is there. The asymptotes. Okay, so let's just think about, and if you want to go and position these on your graph, you know, because you do have a decimal approximation for this C value, it is 7 times square root of 5, but that's the same thing as about 15.7. So the foci would actually be located here if you do want to include it in your graph. This would be 10, 12, 14, 16, 10, 12, 14, 16. So 15.7 would be about right there. So one foci is there, while the other one is at negative 15.7. So negative 10, negative 12, negative 14, negative 16. So the other foci would be about right there. So these things will be opening from the vertex, wrapping around the focus, all lined up on the transverse axis. And then don't forget, before you go into graphing, that you're going to want to use that B value to go up and down, because it will create that auxiliary box. However, answering this last question, you're also going to need the A and the B value, because these asymptotes always include A or B. It's just a matter of which formula do you use. When the graph opens horizontally to the right and to the left, as it is going to do right now, opening from the vertex and wrapping around the foci on this side as well as this side, will cause a horizontal opening. And in that case, the asymptotes go like this. Y is equal to plus or minus B over A. When they open up or down, then it's A over B. And then, of course, this is just the slope of x. Okay, so my B value in this particular case was 14. So this is going to, let's just do it right here. B value was 14. They already supplied the plus or minus, but in my work I'll include it. And then you're going B over A. That A value was 7. Both of these values are up here at the top of the page, which I identified when I first started the problem. And this just simply acts as the coefficient of x. So your asymptotes are y is equal to plus or minus 2x. They already gave you the y, the equals, the plus or minus, so all you have to do is put that. Okay, so now if you want to actually get the graph, we already know that from here to here, from here to 7, that's your A distance right there. So we're going to make a box that goes as far right as 7 and as far left as negative 7. But you want to know how high to go with this auxiliary rectangle. I think I'm going to get this out of the way, just in case it gets in the way of my box. Okay, so now let's see. What was my B value? My B value was 14, so that means I want to go 14 high, 14 low. So 2, 4, 6, 8, 10, 12, 14. Okay, so we're going to go as high as 14 right here, and then as low as negative 14. 2, 4, 6, 8, 10, 12, 14. And again, that A and B value, this is called the conjugate axis. It is the value associated with the negative expression. in its squared form, it will be the denominator of the negative expression. But when you get it in its linear form, in other words, you take the square root of that, that helps you create this auxiliary box. So up B, down B, to the right A to get to the vertex, and to the left A. So make a box out of this. Go from this value of 7 all the way up to 14. Come over to meet it. Go up from -7 all the way up to 14 and close the top of that rectangle. Come all the way down to -14. And then all the way over here, right back up through +7. Okay, as soon as you create that auxiliary rectangle, you can connect the corners, the opposite corners, and that's where your asymptotes go. Okay, if they ask you to name it, which they did, this would be the positive one, because in some problems they're going to say name the positive one, name the negative one. This is the one with the positive slope, and then the one with the negative slope would be the one that goes to the left. So this one is called y is equal to -2x. I'm just adding that to the graph. Okay, don't forget you're opening from the vertices. These are the vertices right here at -7 and +7, and keeping the width of that hyperbola contained within the asymptotes. So that is the picture for number 11. Number 12. Number 12, you start with y squared minus 9x squared is equal to 9. It asks you to find the center, the transverse axis, the vertices, the foci, and the asymptotes. So very similar to number 11. It's just that number 11 started off with 4x squared. It had a positive x squared term, and so the hyperbolic branches went left and right horizontally. Whereas here, because the y squared term is the positive term, your branches are going to open up and down, because those branches always open up with respect to the positive term. Okay, we need to create that one here for this to be graphable. In other words, put it in standard form. You're going to divide by 9 there to create that one, and therefore you have to divide all terms by 9. Whatever you do to one term in the equation, you have to do it to both sides. So whatever you do on one side, you have to do to both sides. So I divided this side by 9, and I divided all terms on this side by 9. That gives you this. Gives you your positive term with the denominator of 9. It gives you your negative term. You got a negative in front of this squared term. These 9s cancel, giving you -x squared over 1. And then 9 divided by 9 is 1. Okay, the denominator of the positive term is a squared. So that's a squared, therefore a is 3. Denominator of the negative term is b squared. And therefore b is just equal to 1. Okay, center of the hyperbola. Notice that this is not y minus anything with a square on a parenthesis. It's just y squared. And the x squared's like that too. So you are still at the origin with your center. Transverse axis, well, again, concentrate on that positive expression, which includes the variable y. Therefore, you're going to open up with respect to the y-axis. Okay, transverse axis is the y-axis. Vertices are going to be aligned on the y-axis. That means you're going to go from the center, and if the vertices are going to be on the y-axis, that means you're going up and down from the origin. So if the origin is, or the center is 0, 0, which is the origin, and you want to go up and down, remember the vertices are all about moving a distance of A. So you're going to be going up. In other words, you're impacting your y coordinate using the y value. That specific A value that you're adding to your y coordinate happens to be 3. And therefore you have one vertex, which is leave the x coordinate alone, impact the y using a 3. So this would be 3. That's one of your vertices, 0, 3. And then the other one, you're going to be moving down. Again, impacting your y coordinate, but because you're going down, you're subtracting 3. So leave the x alone and then go 0 minus 3. And you get negative 3. So that's the other vertex on this hyperbola. Foci, the foci has to do with the c value. You don't presently know the c value, but you can very easily find it using this formula. B squared is equal to c squared minus a squared. Okay, so the b squared value, well, b squared is 1, so we put a 1 there. The c squared value we don't yet know, and the a squared value is 9. So if you were to try and isolate the c squared value, I'm going to have to move over here. You would be moving this to the other side, at which point it would become positive 9. 1 plus 9 is 10. You want the c in its linear form. So it's c is equal to square root of 10. You might want to get a sense of what that means as a decimal for when you go to graph. So I'll put that here for later. But when you're asked to give the foci, they want it in an exact answer. And when you are giving an exact answer, that means you can't give a decimal approximation. Use your radicals, knowledge of radicals. So square root of 10 as a decimal just for later when we graph. Second square root 10. Yeah, it's about 3.2. And we'll use that later. You can't simplify that any further. If you broke this down, it would be 2 times 5, both of which are prime numbers. Therefore, leave them together as a product of 10. Okay, so let's get a sense of how things are aligned by plotting what we already know. We know that the center is at 0, 0. We know that one of the vertices is at 0, 3. Now I think I'm going to space this out a little bit. I'm going to let this be 1, so it's not all crammed in. I'm going to let this be 2, and I'm going to let this be 3. So I'm going to call this point right up here 0, 3. I'm going to do the same thing coming down this way, negative 1, negative 2, negative 3. So this will be 0, negative 3. Notice that the center and your vertices are aligned vertically, and that's because that positive expression contained a y. So everything is aligned on the y-axis. It is the transverse axis. So our foci are going to be on the y-axis. That means that we are going to be going from the center, which is located at 0, 0. Just like we were going up and down to get to either of the vertices, we're going to be going up and down to get to either one of the foci. It's just that now we're going up and down using the c value. Foci are always associated with the c value, whereas vertices are associated with the a value. So it's going to be the y value plus the c value, which turned out to be square root of 10. So leave the x alone and then go 0 plus square root of 10, square root of 10. That's where one of your foci is located. And then if you go down from the center, then you could get to the other foci. Moving down, you take the y coordinate and subtract the distance that you're trying to move, which is the c value. So it would be y minus square root of 10. Okay, using these actual numbers at the center, leave the x alone, but impact the y using this square root of 10. So it's 0 minus square root of 10 minus square root of 10. Okay, if you want to know where to plot that point, because you're trying to plot it on your graph, then you want to think you want to be thinking about the decimal version of it. But for purposes of what they've asked for here, the foci are right what you see here: 0 positive square root of 10, 0 negative square root of 10. And then the other one is 0 positive square root of 10. Hard to jam those in there. Okay, asymptotes. Okay, let's think about the orientation, because based on how things line up, the center, the vertex, the vertices, and the foci, I didn't put the foci on there yet, but if I did want to put it on there, it would be at 3.2. So this would be 4 based on the way I'm counting things. So 3.2 would be about right there. So it's just a little further. This would be, the 3 is where the vertex is, and this is where the foci is. Same thing here. You'd have to go a little bit beyond the 3. That would be where your focus is. So you'd be opening up from the vertex, but wrapping around the foci. That should always be the case, or else you did a calculation improperly. So because we have this vertical alignment, the formula for the asymptotes is plus or minus A over B, not B over A. B over A is when it opens to the right and to the left on those branches. And this A over B is just the slope for the line. So it's the coefficient of X. All right, using those actual values, we would have y is equal to plus or minus. Our A value in this particular problem is 3, and our B is 1. So it would just be 3 over 1 times x, which I'll put here, but I'll put it in its more simplified form here, just so you understand that that's the A, that's the B. Okay, graphing. You need to graph A and B to create that auxiliary box. So we already have A. From the center to the vertex is A. Okay, that is a distance that's on your transverse axis. But if you play out the conjugate axis, create the conjugate axis, you're using the B value. Use B to determine the length of the conjugate axis. Okay, so for our B value, we're only going out 1 over 1. So when I was counting on my y-axis, I let every 2 marks stand for 1. I'm going to do the same thing going this way. I'm going to call this 1, and I'm going to call this right here negative 1. So we're going to go as far as positive 1 to the right and as far as negative 1 to the left. Now create that box. Goes as high as 3, but only as far right as the 1. So the B value just helps with the dimensions of this auxiliary box. Okay, go all the way up to 3, create this rectangle, and then you can put your asymptotes right through the vertices as we have been for all the other pictures. And you've already named them, so you don't have to name them on the picture, but you can if you want to. Okay, those are your asymptotes, and those will control the width of your hyperbolic branches. Okay, we are opening up with respect to a Y orientation right from the vertex, which is at the edge of these boxes right here. So open up from the vertex, and your focus will be right inside each of your branches, your foci. Okay, and that is the graph for number 12. Moving on to number 13. Problem number 13, it says write an equation for the hyperbola shown in the graph. Okay, so notice that this has a horizontal orientation. You have your branches opening horizontally. Therefore, you're going to have this kind of equation. X squared will be your positive term. A squared is always the denominator of the positive term. And then your other term will be the negative term. Okay, look over at the graph and you can identify what A and what B is. Notice that this auxiliary box that I keep talking about, with respect to your A value, that has to do with the transverse axis, where the center, vertex, and even though they didn't plot the foci here, those would definitely be lined up with the center. It goes center, and then you have vertices on either side of the center. And we know that those vertices are arranged right and left because of the way these branches open up. So what you're looking at there is the A value. Okay, now let's see what we have here. This looks like 2, 4, 6, 8, 10, 12, 14, 15. So this appears to be that where I'm hitting right here appears to be right at -5. And this appears to be, it's just a little bit past that. So this appears to be at +5. So what you're looking at right here is an A value of 5. And then if you go as high as the top of this auxiliary box and as low, then that's the B value. Okay, and that appears to be right at 10. This would be 2, 4, 6, 8, 10. And this one hits at -10. So according to this picture, your B value is 10. And with those two values, you can go ahead and write the equation. So this would just be x squared over the A squared value, which is 25. And then under y squared, you would use the B squared value, and that would be 100. And that's equal to 1. And you can put that in that box. That's number 13. Okay, finally in numbers 14, we start to move on to problems that have a shifted center. So instead of being at the origin, we're shifting away from the origin to whatever they give you for the center. So here that you can see that they start you off with 7, -2. So if we plot that, let's see. I'm going to count in ones. I'm going to go 1, 2, 3, 4, 5, 6, 7. And then I'm going to go down to -2. 1, 2. So this will be -2. This will be my center. Okay, from the center, we play out the focus and the vertex. So one of the foci is at 10, -2. So if this is 7, 8, 9, 10, 10, -2, look at how they're all lining up. 8, 9, 10, you're down at -2. So this is one of the foci. And then the other one, just you have to look at how far away this foci is from the center. Notice that it's only 3 units from there. And you could also graph the other foci, because if this is 3 units from the center, then so is the other foci. Because they're always the same distance, but in opposite directions. So this would be 1, 2, 3. This would be your other foci. I'm just going to put a 1 right here so you can see the scale. This is the other foci. The vertex, well, it says that the vertex is at 9, -2. So 8, this is 7 right here, so we're going to go to 8, we're going to go to 9. That's your vertex, so you'd be opening up from the vertex, wrapping around the foci. This was 2 units away from the center, so is the other vertex, 2 units away from the center. Everything is lined up horizontally. So there is a horizontal transverse axis, and you can tell by the way all of the center, the vertices, and the foci line up. And because there's a horizontal transverse axis, that just means that the branches open up horizontally from the vertices. So what they're asking here is write an equation for the hyperbola. Okay, let's recall that the distance from the center to the vertices, you can see that that's 2 units, is the A value, which will always go under the positive expression. The distance from the center to the foci is the C value, and that distance was 1, 2, 3. Typically, in all these problems, you can see that we've been given 2 out of the 3 values that are mentioned in this relationship. B squared is equal to C squared minus A squared. Okay, the B squared value is the one we don't know, but we do need it for the equation, which is why we continue to find it when we go after that equation. We also need it to graph. Okay, the C value was 3, but in its squared form would be 9. The A squared value is 2, but in its squared form would be 4. So B squared is equal to 5. If you want B, then you're going to take square root here, square root here. So B squared is equal to 5. We'll put that in the equation, but we'll use this when we go to graph. And we're even going to want to know a decimal approximation for that, so we know where to position our points to construct that auxiliary rectangle. Okay, as far as the equation goes, we now have the B squared value and the A squared value. Well, the A value, according to this picture, was 2, therefore A squared is 4. So come up here and write the equation. Again, everything's lined up horizontally, even though I haven't completed the graph. Just seeing the orientation of how the center, the vertices, and the foci are lined up tells you that it opens right and left. Therefore, you must use this kind of equation. Okay, now remember, we have a shifted center, so it's not just x squared, it's x minus h squared. That will be our positive expression because it opens horizontally, along a line that's parallel to the x-axis. A squared is always the denominator of the positive expression. Then you have your negative expression, but again, because it's shifted on that y value, the center is shifted away from 0, 0, it's y minus k squared. And then b squared is always the denominator of the negative expression, and then your 1 is right here. That's the formula you're using. Okay, come over here and give the actual values. Excuse me. So it's going to be, and this is your h and your k that this formula talks about. So it's going to be x minus h squared over the a squared value. That a squared value is right here. and then it's going to be y minus the k value. This is your k value. So by the time you go y minus -2, it's y plus 2. Because you're plugging it right into here. You're going y minus the k value. Well, that's the k value. Squared over b squared. B squared is 5. And so we have our equation, and now we also have to complete the graph. Well, as far as constructing that auxiliary box, which allows us to put the asymptotes, and the asymptotes control how wide the hyperbola gets, we already know the a value, so we're going to go this far to make our box, this far right, and this far left. But we have to know how high to go and how low to go, and that has to do with the b value. The b value is approximately 2.2. So from the center, we're going to go up 2.2. Well, we're down at -2 right now, so this would be 2, and a little bit higher would be about right there. And then if we're going down 2.2, let me get this out of the way. Then that would be down 1, down 2, and then just a smidge more. And that's going to help us make the box. So we're going to go over until we get lined up with this vertex. Come straight down, just creating the sides of the rectangle. Okay, there's the auxiliary box. Connect those opposite vertices, and that's where your asymptotes are found. Got one there. And you have one here. Okay, don't forget, you're always opening up from the vertices, which are right here, and keep the width contained within those asymptotes. So we have one branch that opens that way, and one branch that opens this way. Okay, that completes number 14. Here's 15. Find an equation for the hyperbola described. Graph the equation. They give you the foci at 1,8 and 9,8. Okay, but we're not. The center's not mentioned this time, and the vertex is at 7,8. So we're going to figure out how to get our a, b, and c value from the information that's been given here. Okay, so we have one foci at 1,8, and let's see. I think I'm going to count in I'm going to count on my x-axis. My x scale will be 1. This will be, so each grid mark is 1. 1, 2, 3, 4, 5, 6, 7. But going this way, since I have to get to 8 just for the foci, I'm going to let my y scale be 2. Okay, so this will be 2, 4, 6, 8. So this will be 1, 8 right here. And that is, let's see, let's mark what it is so we know what we're working with. That's one of my foci, 1, 8. And then my other foci is at 7, 8. So this will be 2, 3, 4, 5, 6, 7. And then we're coming up here to do the other foci. Okay, so we have one foci at 7, 8. We have this foci at 1, 8. And the center is always situated exactly in the middle of the two foci. It's also situated exactly in the middle of the two vertices. So you can tell what the center is right now, just from the two foci. The center is the midpoint of the two foci. So you could just count the distance here. If you're going from 1 to 7, that is, let's see, 1, 8. We also have, nope, I think I marked this wrong. I used the 7, 8, and that was supposed to be 9, 8. Let me correct that, please. Okay, so this one of them was at 1, 8. I was looking at that accidentally when I plotted the other one. The other one was at, this is 7, 8, 9. The other one's at 9, 8. So this is the other foci at 9, 8. So what I was planning on doing is just counting the distance between these two. Notice that from here to here, the distance between the foci between the two foci is 8. So if you just cut that in half, that means that it's 4 spaces from either foci to the center. Okay, so if you're going to move in 4 spaces, this would, from either this end or this end, it doesn't matter which one you do it from. It's 1, 2, 3, 4. That's where your center is going to be. And knowing that center is going to help us to write the equation. So this center is located at 2. This would be 1, 2, 3, 4, 5, and 8 units up in the air. Okay, remember, the coordinates at the center are called H and K. That means you have shifted away from the origin and to some other location, that location being 5, 8. Okay, so your center is 5, 8, and that represents H, and the y-coordinate represents K, which is part of the formula that we're going to use when we write the equation. We can also start telling things from the values that they've given, specifically just from the foci. We can tell what the value C is. So from the center out to the foci, that is a value of C. Okay, from center to foci is your C distance. That's known as the C value. If you want to go from the center to the vertex, then you have the A value. What is associated with the vertex is the A value. So A in this case, let's plot. They gave us the vertex right here. It's at 7, 8. So this was at 5, 6, 7. So right there is a vertex at 7, 8. Notice that from the center to the vertex, there's 2 spaces here. So that A value is 2. And I can tell these things just by plotting the points and looking at the graph. I plotted my center, then my vertex. Notice there was 2 spaces. That's always the A value. I also looked at the distance between the 2 foci, which was a total of 8. Therefore, it was 4 to get to either of the foci. And that depicts from here to foci the C value. Okay, so now I know quite a few things, and I'm on my way to writing the equation because now I have 2 values out of the 3, and the formula that we learned that relates A, B, and C will allow me to get B so that I can finish this equation. So it's B squared, once again, is equal to C squared minus A squared. Okay, we don't know B squared yet, but we do know C squared. This is C, therefore C squared is 16. A value is 2, therefore A squared is 4. So B squared is 12. If you want B in its linear form, then you have to take the square root. Okay, and square root of 12. You can, give it in its simpler form, but you don't really need that based on the question. You don't really need to do a partial square root here based on the kind of questions they're asking you, because you're just going to use it in the equation, and that calls for b squared. And when you go to use it for the graph, you're going to need it in decimal form. So b squared, your b is square root of 12, which is also, I'll just write it like this just to give you practice. This is 4 times 3. You could also write that b is equal to, take the square root of this. You don't really need it, but 2 square roots of 3 is the partial radical form of square root of 12. Both of them are equal to approximately 3.5, just for graphing purposes, because when we're graphing and we're trying to move to the right or the left or up and down, we don't think in radicals. So decimals are more convenient to use, more practical. Okay, so as far as getting the equation now, again, look that we have a horizontal orientation. Therefore, you're going to be using a horizontal orientation, or what we call a horizontal transverse axis. Okay, which would be x squared over a squared, but since it's a shifted center, it's not just x squared, it's x minus h squared. The a squared will still be associated with that positive term. And then instead of y squared over b squared, it's y minus k squared. And we know, once again, we know the h and the k. And we also happen to know the a squared and the b squared at this point, so that we can continue this equation. Okay, so it's going to be x minus the h value. Come look at the center. This is your h, this is your k. So it's x minus 5 squared over the a squared value. That a squared value is, well, here's a. So if this is a squared is 4. Then it's minus y minus the shifted k value, which is 8 squared over your b squared value. And b squared was 12. And that's equal to 1. So that's the equation that you're going to be giving right up here. Okay, x minus 5 squared over 4. And then y minus k squared, or y minus 8 squared over 12. And that gives you the equation. If you want to complete the graph, then, well, we already know our a value is this way, so that'll help us do the sides of our box. If we move 2 units this way to get to one vertex, then it's 2 units to get to the other vertex. Okay, and then if we're going to know how high and how low to go, then that's a matter of what the b value is. That b value as a decimal is approximately 3.5. And according to what I'm doing here, each one of these grid marks counted for 2. So this would be 2, 4, 6, 8. We were counting like that along the y-axis. So I'm going to have to move some of this stuff out of the way so that I can continue my graph. It's nice to label it while you're doing it. Do these in pencil, because then you can just go in and erase. Okay, so from this center, it was 2 to get to either one of the vertices, so those will be the sides of this auxiliary box, and then I'm going 3.5 units up, 3.5 units down. So remember, each grid mark counts for 2. So this would be 2, 4, 3.5 would be about right there, and then this would be down 2, down 4, 3.5 would be about right there, and create that auxiliary box. Okay, then run those asymptotes right through opposite corners of that auxiliary box and open your hyperbolic branches from the vertices so that they wrap around the foci. But stay contained within the asymptotes. Okay, and that's the graph and the equation and all the analyzing that you did to get the various values you needed for the equation and the graph. Moving to number 16. Find the center, transverse axis, vertices, foci, asymptotes, and graph the equation. Okay, this is also a shifted center. And it's also not in standard form. You need to have a 1 right there. But you can tell what the center is even without doing that. Okay, that's your K value. Because remember, K is always found with the Y expression. So this is really Y minus K squared. And this is X minus H squared. Okay, so a 1 has to be the K. So there's the Y, there's the minus, they must have plugged in a positive 1 for K. So the center is, don't forget, your center is always listed H first, then K. Okay, the H value that must have been plugged in right here had to be a -2 for it to end up like this. So your new center is at -2, +1. Okay, then if we're going to get this in the proper form, we need to get a 1 right here. So divide by 25, divide this side by 25. That means divide all terms by 25. Okay, that gives you this. You have your positive term, y minus 1 squared, with a denominator of 25, because it's 1 over 25. Here the 25's cancel in your negative term. Okay, this is your negative squared term. And now the denominator is just 1 because the 25's canceled. And then over on the right side, you have a 1 just as you intended. Okay, underneath the positive expression, that denominator is always your a squared term. Therefore, a is equal to 5. Underneath the negative expression, that will be your b squared term, and therefore b is equal to 1. It's just the square root of that value, square root of that value. Okay, let's see, what kind of questions do we have here? What is the transverse axis? Well, the transverse axis is all about the positive expression. And if the positive expression contains y, then the transverse axis, we're not going to actually say it's the y-axis because the center would have to be at the origin for it to be the actual y-axis. But it is a line that is parallel to the y-axis. So that would be the answer there. In other words, we have a vertical orientation happening here. So in other words, once you plot the center, you're going to go up from the center, down from the center to get to the vertices as well as the foci. What are the vertices? Well, knowing that the transverse axis is vertical helps you to understand that you're moving up and down from the center to get to the vertices. Okay, so in this particular problem, let's see, what was the center? The center was -2, 1. So we're going to take -2, 1, and we're going to move up and down to get to the vertices. Okay, from the center to either of the vertices, you're talking an A value. We're moving up, therefore we're impacting the Y coordinate with the A value. That A value happens to be exactly 5. So the vertex that's above the center point would be leave the X alone, but impact the Y coordinate using 5. It would be 1 plus 5, 6. That's one of the vertices, -2, 6. And then the other one would be -2, but this time we have to go down from the center. Once again, only impacting the y value, but this time through subtraction since we're going down. Okay, that specific y value is 5, so leave the x alone, take the y coordinate, subtract 5. So that would be -4, and that's the other vertex. Okay, what are the foci? Well, I can do the foci in the same manner, only you have to understand that just like it is the a value that you use in order to find the vertices, you move a distance of a from the center to either one of the vertices. I got the vertice above it by moving up a units on my y coordinate, and I got the bottom vertex by moving down a units, and that's how I got both these answers. Well, the foci is associated with C, so I'm going to take that same technique, moving from the center, moving up C units, down C units. Okay, I'm going to do that here. So let's see, I don't know if I'll have room here. So this will be -2, 1. That's my center. And if I want to get to the foci, I have to take my y coordinate and add whatever the C value was. And that C value, do we even know that yet? Let's see. Let's check that out. I don't believe we have that C value yet. So we could find that right here. We could go b squared is equal to c squared minus a squared. We do know the b squared value. That's 1. There it is right there. We don't know the c squared value, but I sure need it in order to do these foci. And then the a squared value is this 25. So I could move this over here, at which point it would be positive 25. And I would then have c squared is equal to, once this moves over here, 25 plus 1, 26. Okay, so that the c value itself would just be the square root of 26. If you need it in decimal form for purposes of graphing, it is 5.1. But when they ask you to give the foci, they really want an exact answer. So if you're going to put the foci in the graph, you can think of it as a decimal approximation that, you know, square root of 26 is approximately 5.1. But as far as giving an exact answer, as they have requested right here, you're going to need to use it in its radical form. That's what's exact. Okay, so my foci. I am taking that C value and adding it to get the foci that's above the center. And that would be, leave the X as is. Take the Y coordinate and add that C value. Okay, and you're not actually going to add those. You leave it just like that so that it's in exact form. So that's one of your foci. And if you're going to go down this way, then you're going to take the y coordinate and subtract that c value so that the other foci, the one that's below the center, this is just home base. You're moving up to get to one foci, down to get to other foci, because everything is vertically aligned, which we knew from the beginning of the problem, from this positive expression and the way that it contained. It was made up of the y in the numerator. Okay, so if you want to move down, it's leave the x alone. Always subtract when you're going down on that y coordinate. So it's 1 minus the c distance. And that's your other foci. So these are both of the foci, here and here. Okay, with regard to the asymptotes, again, you have a vertical orientation here. Anytime your y expression is positive, you will have a vertical opening of your branches. It opens up and down. Everything's aligned vertically. And when that is the case, there is a specific formula for the asymptotes. Hyperbolas that open vertically like this have this formula for their asymptotes. It's y is equal to plus or minus a over b times x when the center is at the origin. However, in this particular problem, you saw from the very beginning that your center had been shifted away from the origin. It's not at 0, 0. And the way that that alters these asymptote formulas is that instead of y, it's y minus k. And instead of x, it's x minus h. Your x and your y get altered in that manner every time you shift away from the center. Your center in this particular case, your h and your k, happen to be -2 and +1. So that when you go to give this these asymptotes, your y minus your k value is equal to plus or minus a over b. Your a value is 5. You can see that up at the top of the paper. This was a squared, therefore this is a, and b was 1. I'm just going to put the 1 there just so you don't wonder where I got it. And then it's x minus h. So x minus -2 is x plus 2. Okay, go find the equations in the choices that you have right here. So you have y minus 1 on the left, therefore it can't be this or this. And you don't have 1 over 5, it's 5 over 1. So that would be this choice right here. Y minus 1 on the left, x plus 2 in parentheses on the right with a slope of 5, plus or minus 5. So it's this one. Okay, if you're going to take that all the way into the form of a graph, then we're going to plot the center. And the center was at -2, 1. So this is, I'm just going to count in ones. -2 is right here, +1, that's your center. Okay, and then the vertex is aligned with this center. It was at, the vertices were at, let's see what we got there, -2, 6 and -2, -4. So this will be 1, 2, 3, 4, 5, 6. This is -2, so -2, 6 is right there. And then -2, -4, this would be -1, -2, -3, -4. This will be -2, 4. Okay, so we already know that this is this A value right here. We're going to go as high as 6 and as low as -4 with this auxiliary box that we're going to draw. Okay, make sure these are the same number of units. So this was 1, 2, 3, 4, 5, and from here it was 1, 2, 3, 4, 5. So you're good. Okay, then we want to know how far to stretch it this way and this way, and that is dictated by the B value. So this is called the transverse axis, where the center and the vertices happen. And the foci are there too. I just don't need them right now in order to get this graph going. You can put them in there though. And then when you move this way and this way, that's dictated by the B value, also called the conjugate axis. So our B value was, let's see where that is, 1. So we're going to go from the center. Everything's measured from the center. We're going to go out 1, and we're going to go to the left 1, to the right 1, and to the left 1. And then we construct that box where we go from our greatest width to the right, line it up with how high we're going to go. Going out this way, coming, so we have this very skinny auxiliary box. Up through there. There's our auxiliary rectangle, and we can create our asymptotes just by going through the 2 corners. That's one of them. And we can go this way. Get the other asymptote. And then just as we have in the other problems, we're going to open up right from that vertex and stay contained within the asymptotes on our width. And that would be the graph for number 16. The last problem in this crazy section, so long because it's very detailed. Okay, same type of question. Find the center, transverse axis, vertices, foci, asymptotes, and graph the equation. Okay, here you're getting practice on completing the square. So, completing the square, if you have forgotten it, we're going to end this section with a bang because there's a lot of work here. So, you're going to get the X family together, and I'm going to move up as high up on this page as I can so I have all the room that I can, all the room that this page has. Okay, so we got X squared, and we also have a negative 10X term. So, let's group those X terms together and leave room to complete a third term, in other words, to create a perfect square trinomial. Those are my X family members. I'm leaving room to create that third term. Then we have negative, group all your Y family members. You want to make sure that by taking this negative out here that you still have the same terms you created. So if I put a positive y squared here, that negative makes it the negative y squared that you saw right here. And this is a negative 16y. Well, by me putting positive 16y, that negative on the outside of the parentheses takes care of it, making it a negative 16y as it appeared in the original problem. It's just that you have to pull it out while you're completing the square. So I did my x's, I did my y's, this negative 64, any of the constants, so close this up, leave room to create that third term, and then the constants you can just bring to the other side. This is how we prepare to complete the square, by grouping our X family members, leaving room for a third term for each family. And you can only complete the square when you have a squared term and a linear term belonging to the same family, because sometimes both families can't be completed. They can in this case, though. And then don't forget to move the constant to the other side. Does it need to be on the side where you're completing the square? Okay. So we are going to try and find the center of the hyperbola, which is why we're completing the square. So you might want to put that in your notes. You complete the square to find the center. Because if we can't find the center, we can't find the vertices or the foci or any of those things we need. Complete square to find the center. Okay, so here's a review of completing the square. You cut the linear coefficient in half. Turns out to be negative 5. You then take that number and square it. And what you get is 25, because squaring anything results in a positive, and that is this third family member. Remember that whatever you do to the left side of this equation, whatever you create that's brand new and has just been introduced into this equation, you must counterbalance by adding that same number to the other side. Whatever you do to the left, make sure you do it to the right, and what was added was a positive 25. Okay, now let's complete the square on the Y family. So again, same two steps. Take half of that linear coefficient, which is 8, and then square it. You would get a 64, and that is the number that completes the square. Remember, whatever you do to this side, you must do to this side. Now, I know that looks like a positive 64, but because of the negative out here, you're really creating a negative 64 here. So you need to create a negative 64 on this side. Okay, now we're going to take each of these, what are called perfect square trinomials. Okay, it's a perfect square trinomial, which are created by completing the square. We now have trinomial families, and they all factor like this. Any perfect square trinomial will factor like this, and they're very easy to factor. You just take the square root of this front term, which is x. You take the square root of this back term, which is 5, and you join these two terms by the sign in front of the linear term. Okay, let's do that on this other family, on the y family. This is also a perfect square trinomial, which is always what you're creating when you complete the square. Perfect square trinomials always factor like this. Some binomial squared. Take the square root of the front term, take the square root of the back term, join these two terms by the sign in front of the linear term. Okay, collect the numbers together into one number. Just combine them all. So 64 cancels with negative 64, and all you have is 25. Getting pretty close to being able to use it for graphing purposes, but we can definitely tell what the center is at this point. This is x minus h that you're seeing here. Squared, therefore the value that must have been plugged in for h for it to look like this had to be positive 5. This represents y minus k squared, so the value that would have had to have been plugged in right here after a minus sign to turn into a positive 8 would have to be negative 8. Okay, so we have the center so far. Now, if we want to get this in the proper form for graphing, then we know that we need a 1 right here. So we would have to divide by 25 here. We'd have to divide this by 25. We'd have to divide this term by 25. So what it would look like at that point is x minus 5 squared, 25 as its denominator. And then, let's see, then the y plus 8 would also have 25 as its denominator. So we do end up with an auxiliary box, auxiliary rectangle, which I've been calling it. That's actually a square in this case. Okay, I just divided everything by 25. This became a 1 as is required when you're going to graph. This expression, it had a 1 in front of it, so 1 divided by 25, the 25 is down there. And same thing on the x expression. X squared minus x minus 5 squared divided by 25 looks like this. So this is what we're graphing. Okay, so transverse axis, notice that it is the x expression that's positive. Therefore, this has a horizontal transverse axis. That positive expression dictates which way the hyperbolic branches open. They open horizontally because there's an x in the positive expression. So transverse axis is parallel to the x-axis, horizontal orientation. Therefore, the vertices will be stretched out to the right and to the left of the center. So going from the actual center here, okay, so let's see. I don't know how much room I have right here. Okay, so the center is at 5, negative 8. And if I want to get to the vertices, I'm using the A value. Very much stressed in this section. Moving from center to vertex, you're using the A value. If I'm going to keep a horizontal line up so that I can have hyperbolas that open left and right, that means I'm moving horizontally, therefore I'm impacting my x coordinate. So it's going to be the x coordinate. I'm moving to the right, I'm going to add the A value. The A value in this particular case, well, let's look at this equation. This is A squared, and therefore A is equal to 5. The B squared value also happens to be 25. So B is equal to 5, and so is A. Okay. So I'm going to take the X value, and I'm going to add that A value to get to a vertex. So it's going to be the 5 that I'm on, add another 5, and you're at 10, -8 when you move to the right. And then when I go this way, I'm taking X and I'm subtracting that A value, which again is 5. So the leftmost vertex would be 5 take away 5, 0, while leaving the Y coordinate as a -8. So those vertices end up being 0, -8, and 5, -8. All right. Foci. Foci is associated with the C value, but same deal. You're going to go from the center and you're going to move C units in a horizontal direction because everything is lined up horizontally. You have branches that open to the right and to the left. So if I'm at 5, -8 and I'm trying to move this way, taking the X coordinate and I'm adding the C value. So let's see, have we yet to calculate the C value? I don't think we have. So we're going to have to come over here and do that C value. So the equation goes like this. It's B squared is equal to C squared minus A squared. So B squared is 25 because there's your B value. C squared we don't know yet. And the A squared value, let's see, that A squared value is 25 also. So when I try to move this -25 over here, it's positive 25. Therefore, C squared is equal to 50. Okay, you're just moving that over here. 25 plus 25 is 50. The C would be by itself. C squared would be by itself at that point. So if you want to know what the C value is, then of course you have to take the square root. So take the square root. Take the square root, and you have C is equal to square root of 20, square root of 50. They're going to want you to give exact answers for these foci. That means keep it in radical form. Okay, so let's see, how do we get a radical here? This would be 25 times 2. You could take the square root of 25, which would come out as a 5, leaving the 2 underneath. There's your C value. So now you're going to use the C value to get the foci. All right. So we're moving right and left with the C value. So we take the X and add on that C value and leave the Y the way it is. So that's one foci. And then we're going to go this way. And subtract the C value. And that C value once again is 5 squared roots of 2 with a -8 as the Y coordinate. So that's one of the foci. This is the other one. Please excuse me. I cannot continue. This is too long of a video. Just can't keep talking. All right, so you have all of that. Last thing, thank goodness. I don't think I have a voice left here. Is the the asymptotes and the graph. So let's think about this. We have a horizontal orientation here. But right back up to this, that you have these hyperbolic branches that open to the right and to the left, which we knew because the x expression was positive, which tells you what the transverse axis is. In other words, the direction that the branches open up in. So because we have that horizontal orientation, that tells you what the formulas are for these asymptotes that we're about to find. Okay, so your formulas are going to be now, keep in mind that you have a shifted center. So instead of it being y is equal to, okay, for horizontal hyperbolas like this, it would be b over a plus or minus times x. Now that would be if the center was at the origin. But the minute you get into a shifted situation, the y becomes y minus k. You don't have to put a parenthesis there. And the x becomes x minus h. So what the x and the y turn into, just like they turned into that for the general equation of the hyperbola, they also change into that for the formula for the asymptotes. Okay, so it's y minus the k value. Look, here's your h and k value right here. This is h, this is k. So when I go y minus k, I'm going y minus negative 8. And then I'm going to go plus or minus b over a. And they said they just want the asymptote with the positive slope. That means I can just give the positive one. Okay, let's see. So my b value was what? 5. Here it is right here. Just a mess of information. My a value was also 5. And then this would be x minus h. And my h is, let's slide down. Let's look at the center. This is my h right here, x minus 5. Okay, they only wanted the one with the positive slope. That's why I'm not giving the negative one. All right, so we have y plus 8 is equal to 1 times x minus 5. 1 times x minus 5 is just x minus 5. And when you have, an equation this simplistic, they're going to want you to go a little further. In other words, like isolate the y. What's any more complicated than that? They let you alone. But in this case, they'll expect you to give this. Okay, that is the asymptote with the positive slope. Y is equal to x minus 13. Okay, in other words, I only used the positive slope. I didn't bother to use negative 5 over 5. Okay, so finishing this off and doing a graph. Remember, I'm going to need A and B to stretch out that auxiliary box, run the asymptotes through opposite corners, and open up in the proper direction from the vertices. So my center was at 5, negative 8. I'm going to count in 2's on my x-axis. So this will be 2, 4, 6, 8, 10. And along my y-axis, let's see, my vertex was at, my center was at 5, negative 8. So 2, 4, 6, 8. On my y, I'm going to count the same way. Okay, so if I'm going to 5, this would be 2, 4, 6. So 2, 4, 6. If this is 6 right here, then I'm coming right here between the 4 and the 6, and I'm dropping down to 8. This would be 2, 4, 6, 8. This would be negative 8. So this is 2, this is 4, this is 6. I'm going to come right down here from 5 and drop to -8. That's my center. All right, then this was horizontally aligned from the center. I moved to the right and to the left to do my vertices, but I already know what my vertices are because I did all these calculations. So at 0, -8, I have one vertex right there. And then I also have another vertex at 10, -8. So I'm going to go 10, -8, and I have another vertex right there. My foci, if you do want to put the foci in there, then you would have to know what the C value is, which I don't know that they've asked you to put those in there. You can put them in there if you want to, but you would have to know what the approximation is right here. This 5 plus 5 squared root of 2, that's approximately 12.1 with a y coordinate of -8. And this right here, 5 minus 5 square roots of 2, that's approximately -2.1. If you do want to plot the foci, but I don't think it's required when you go into MyMathLab to actually plot the foci points, but you'll have to see when you go in there. They may ask you for it. So the foci would be at, this would be 12, and then 12.1 would just be a smidge to the right. The foci, and then the other one was at -2.1. So let me get rid of this. So this would be going this way. This would be -2, and just a little bit further. That would be the other foci. I don't know. The foci just kind of give you, an idea that they just kind of confirm that you're opening in the right direction, because you're always starting from the vertex and wrapping around the foci. So that kind of forces you into opening it in the right direction. So we know from here to here is the A value. My auxiliary box will go as far as 10 and as far left as 0. And then how high I go would be controlled by the B value. And that B value was 5. So this would be 5 units away. So I am down at -8. So if I wanted to go 5 units up, I would be at -3. So that would be right here, but lined up with the center right there. And if I wanted to go 3 units down, then I would be at -11, because right now at the center I'm down at -8. So this would be -10, and then one more would be -11. Okay, so if I go to do this, let's make sure that I am 3 units away. This would be 2, 3. And from the center, this does not look right. Okay, let's check this out again. My B value is 5. I didn't go far enough here. So I'm going to lose it. Too much. Okay, so from here I was going to go 5 units. So I was at 8. And I ended up at -31. I went 5 units. And then I was supposed to go 5 units down this way. So this was 2, 4, 5. Now I got it. So this goes like this. Okay, so you have your box here. Go through opposite corners. That'll create your asymptotes, and then you're opening horizontally from the vertices that you've plotted, but wrapping around your foci to give you a horizontal orientation. And that completes section 10.4.